So welcome to the lecture, guys. We'll start in about 2 minutes because starting at 8:30. Yes, Unit 2 is logs and exponentials. So in the meantime, while we wait for people to slowly join, if you've had spring break, do you have fun during spring break? And if you haven't had spring break yet, are you excited for spring break? Boring. Spring break was boring. C. Okay. Boring. Okay. And here's a link to tomorrow's lecture because this is content. Do you remember what happened yesterday with the gym kit? I had work over break, so I couldn't truly relax. Yeah, and I haven't started. You still have time, don't worry. You still have another month ish for the exam. Okay, we will be getting started about now. Okay, so welcome. Today we'll be going over what the AP Precalc exam day will look like and calculator review. And the reason for this lecture is that some schools don't teach AP Precalc in the order you teach it. So first of all, this is from hosted by Five Hive, and check out our website because Precalc's website looks actually pretty complete. For example, if you look at Precalc, most of the articles are done except 1.5 and 1.8, and so Unit 2 and 3 are done, and most of the MCQs are done for Unit 3. And Unit 1 and 2 should get MCQs shortly, hopefully before the AP exam. And if you would like to apply, the link to apply is right here. Interested in applying, you can use this link to apply and you can host lectures if you've gotten a 4 or 5, or you can join another team and work for their team. Okay, they made it easier. Okay, and Insta, TikTok, and website. Oh, and a disclaimer: AP is a trademark registered by College Board, and we're not endorsed or affiliated with 55. Quick 3 expectations: don't do something that'll get you banned. Pretty much follow all server rules. Be kind to each other. Ask questions. There are no dumb questions, so always ask them. And a mistake made now is a mistake you won't make again in the future. Okay, and so last year, after the AP exam, so like score release time, we asked people what they got that if they attended 5 lectures. And if you see, 73% of people got a 5 and 90% of people got a 4. So, yeah. And to answer the question, do lessons 2.1 to 2.3 appear in the exam? Yes, they do, and we will go over those topics tomorrow, which are sequences and series, and I think the story of exponentials. Okay, so the exam structure and units. There's 3 units: polynomial rational functions, exponential log functions, and trig and polar. So the first section is your non-calc section, which has 28 questions and 80 minutes. And for this section, you want to make sure you don't have your calculator out. And for the next 2, you can have your calculator out. And sometimes your exam proctor will warn you to take your calculator out or to bring it out. So make sure you know when to bring it out depending on the section. And for the 2 calculator sections, you do get Desmos if you like Desmos, and it's built into Blue Book. So first unit is like the polynomial functions, rational functions, and like the basics of transformations. Are they going to clear your programs? Depends. Some do, some don't. They're supposed to, but most don't. Second, unit 2 is changes in sequences and exponentials and logs, and then we end with semi-log plots. So for 2.1 to 2.3, that would be your sequences, and that would be like the basic of exponential functions. And then Unit 3 is split, for our purposes, are split into 3 lectures. Our first one will be covering this and 3.8. Our second one will cover 3.9 to 3.12. And our third one will be all about polar. So our this first one will be held next week, and the other two are held later on. And then finally, FYI, Unit 4 is not tested on the AP exam. So parametrics, vectors, and matrices and conics are not tested on the AP exam. So if you learned it, good that you learned it, but you don't have to know it for the AP exam. So now we're going to go over what the 4 FRQs look like. So the first FRQ covers something called function concepts. And you usually get one equation. So g of x is usually an equation, and f of x is a table, a graph, something like that. And first part usually is similar, composition of functions and inverses. Second one is zeros and limits, and limit and behavior. And part C is usually determining the type of thing, and it varies, and it's usually about rates of change. FRQ2 is modeling a non-periodic context, or pretty much using a calculator to make a regression to figure out your A, B, and C. And it's a function that isn't a trig function, and you're going to be calculating rates of change and appropriateness of models. So these first 2 FRQs you get a calculator for. FRQ3 is the first non-calc FRQ. And it has 3 parts. The first part is plotting your points. So you do that based off reading this information above, and you figure out where your midline is, and you start from there. And it's based off a real life scenario and making an equation on those points and looking at the rate of change of function. And then finally, FRQ4 is doing algebra pretty much. It's solving exponential, logs, trig, and inverse trig equations. And it's just a lot of setting them, set stuff equal to each other, solving for values. And this is also another non-calc FRQ. We've seen this exact FRQ. Yeah, this is these are all 2025 FRQs. That's fine. Okay. Next. No, there's more. That's the overview. Yeah, that's all the exam is. So you've learned the exam now. So that was the point of this. So now you know, yeah, that's the 4 FRQs. That's the 4 FRQs. And now we're going to go and look at some recommendations from previous year students who responded to questions of the days like you've seen in the channel. So I'll just zoom in. So there's tons of suggestions. So you can find this with this link right here. So if you'd be interested in looking at the suggestions from last year, it's on the second tab. And these are like what resources were most helpful. If you didn't get your dream score, what you wish you did. And then this is just me going through and like counting how many each one was said and ranking them. So this is just people giving their answers. So popular options are practicing, looking at using the server. A lot of people last year liked asking questions in the AP Precalc channel. They found it very helpful, as you could like get your questions answered and stuff like that. The Brian password MCQs, which can be found on the resources doc, which is our next slide. But there's Brian password MCQs and FRQs, and they have like over, I think like 180 for this one. Yeah, 180 for unit 1, and they're like all AP style. And there's more resources if you'd be willing to check it out. So that's the resources page, and the Discord was another popular option. So now we'll go on to Desmos /TI84. If there's any questions about, we'll start with Desmos first. So is there anything you want to see on Desmos, except like the basics involving them? Table regression, okay. So first, let's start with table regression. So we're going to type table, or you can also enter table from up here. And we're just going to enter some random numbers. And then with the new Desmos, this is College Board's version, which I will send in the chat. And for this, you can just click this button and it makes the regression automatically for you. The button in the top left corner, you can click and it'll automatically make the regression for you. And then from there, you can choose whichever regression you want to use. So if you know it's quadratic, you can put a quadratic. You can do cubics. Can you copy paste an AP? Like the magnifying glass? Yeah, you can also do this if you want to scale your data. Will it let me open Google and open Desmos? So on the AP exam, Desmos will be like in this top right corner, and it'll be like built into Bluebook or the testing platform. It's called Bluebook. Yeah. So this would be how you would do regressions. And then we're gonna try graphing inverse functions. Let's check. Let's just say we have 2x squared. Let's check. I don't think you can do inverses. Yeah, I don't think you can do inverse. You can maybe do it the way f of x equals y, maybe. Hold up. There's a suggestion in the chat to do it like this. Yeah, that's one way to do it. You could do it like this, how it's suggested in the chat, by doing two different equations. Semi-log graphs on Desmos. Yeah. Is it allowed in the log settings bar? So yeah, you would go to graph settings. So now we're gonna go into the second part, which is like, so you can make your y-axis log, which is how a semi-log plot works, or it could be x, depends on what the graph gives you. And so now we'll graph like 2x, and we can see it becomes linear because that's how a semi-log plot works. So we can change it like that. We can also go into polar mode, which is you can change the grid. So now we have a polar grid. So we can do our polar graphs here. So we can have a cardioid and stuff like that. So if you'd want to do graphs in polar, you could do polar and stuff like that. Any other questions involving using Desmos? Make a Lemicon, okay. Sec. Oh, that's an inner loop. Yeah, that's a loop. It's a Lemicon. So yeah, if you want inner loop Lemicon, you could do this. So you can make stuff on here using the polar graphs. Is there any other questions related to what you want to, what test days like in Desmos? I also have a TI-84 one, so if you have questions about how to use the TI-84, I could also pull it up. Is being a lecture going over Desmos on the AP Precalc exam? So that's what this is for. So that's what this lecture is, to go over Desmos on the AP Precalc exam. So you would use it for regressions. You could use it to do function analysis. So like example, let's say we have this, we can find our maximum minimum. If we had more, like we can find our maxima, minima, x-intercept, stuff like that. We can find our end behavior using Desmos. So that's where you would use it, to do this, or to like calculate slopes and stuff that you can't calculate using paper. These lectures are recorded, and the slideshow is on the lecture calendar, which I will send a link to. And you can find the links in where this lecture is located to the slideshow. And that's really it. So if there's no other questions involving Desmos and stuff, now it'll just be an open Q&A. So you can, like, if you have any questions that you've seen before, we can go over them, have a whiteboard, and we'll just go through them together, and it'll just be a work together session. So, any questions? Or would you rather just go through like one of these MCQs? Like unit 1, 2, or 3 brand password MCQs. Well, these practice tests are on AP style, so that's the reason I didn't choose those. I only chose these two because these are the AP style ones. Yeah, you can't, if it's from a college board one, you sadly can't send it unless it's a released test, which I'm assuming it's not because there's no released pre-calc tests as of the moment. One guy on YouTube did the whole practice exam one. Well, if he gets caught, his YouTube's going to get taken down. And this server, you get banned for that, so. And we don't break rules in here. Can you go over the chief readers report from last year's FRQs? Sure. Let me search it up. Is it out? Yeah, it is. Okay. So, what do you want me to, like, just go through the 12 pages, or what do you want me to do with the chief reader report? The FRQs? Okay. Like the scoring stuff? Yeah, so you want me to go over scoring guidelines like these? I'm assuming this is what you mean. Probably. Close enough. Okay. Oh yeah, for decimals, do 3 decimals rounded or 4 decimals truncated. Or that, so pretty much that means do 1 point. If our decimal, let's say it was 1.31462, for example, we would round it off or do this and truncate it. So at 4 decimals. Doing this might sometimes lose you points and probably will. So always remember to round to 3 or truncate at 4. Oh, wait, one sec. My screen share broke. Okay, that should be fixed now. Okay, so you can't truncate with 3. You have to round it 3. Your tip is always to use 4 decimals. That's like the safest option. Just do 4 decimals and you're good. 4 decimals is the safest, and even if you do choose not to round, it doesn't matter. Stuff like that. Better tell your teacher about this. And as you see on the scoring guidelines, it says the first decimal representation error in question 1 does not earn the point. For each additional part of question 1 that requires decimal approximation, you can take decimal. So pretty much you only lose the point once. You won't lose it every single time. And decimal places must be accurate to 3 by rounding or truncating. And remember to show your work. So like even if you got 0. Like for this, show 0.33, you should always show your work, like doing G of f of 1, then G of 1.75. So I can make 1.2346. I would recommend just writing all of them. I'd say it's safer always just to go to 4 decimals so you don't lose the point. Because if you forget to round, then you lose the point. Round or go to 4 decimals, yeah. So for your example of 1.346, you could do 1.235 or just write the entire thing. Exactly. No, it's wrong. It's truncated to 4, not truncated to 3. Yeah, okay. Besides the point, recommended is 4. We don't have to spend a ton of time on this. Yeah, pretty much. Okay, any other questions? I'm asking people in pre-calc committee, can you go detail about each FRQ? Sure. Okay, so as I'm gonna open both 2024 and 2025 so we can look at both of them at the same time to talk more about what's there compared to going over the exact answers. So as you see, for both 2024 and 2025, FRQ1 has an equation and some type of alternate representation of a function. So this one gives you a table, but this one gives you a graph. And also gives you a graph here. And both parts of the first one are covering composition of functions. So plugging in one to find the other. And you do that same one and the other one. So that's always the first part of each FRQ. Second part is finding, for this one was finding an inverse. For 2025 was finding the inverse of f of 3.5, which would be just 0. But for this one, it was finding values for which f of x equals 1. So you would just be putting like a line here and checking, putting y equals 1 and checking where it intersects f of x. So that would be at -3, 0, and 3. For part B, dot I, you would be finding where g of x equals 2. So you would have to use Desmos for this. So you would set these equal to each other and find and list all decimal approximations. For this other one, you're doing a similar thing with using Desmos / TR-84 and finding where they're equivalent. So a regression, yeah. Or you could also, so you would say like g of x equals, I'll take a screenshot of this real quick. So I'll have to keep going back and forth, but third plus x squared 0.834. And we're setting it equivalent to 0, so we're gonna just set y equal to 0, and we're gonna see its equivalent at these 2 points. So you would write down this and this as, so you would say x equals those 2 points, and you would do a similar thing here. For this one, you would look at the graph and figure out where it increases without bound, which means as it approaches positive infinity. So as g of x, so this function approaches positive infinity, where does y go? And you would use the mathematical notation of a limit, which would be just like limit x goes to infinity of the function equals this. Can we put in all 5 Yeah, you could do that as well. Yeah. If this decreases, yeah. If it says decreases towards bound, you're going towards negative infinity. So, yeah, that's pretty much it. And then you would do the same thing here. For this one, you would for C on 2024, you said isn't an inverse, and you would pretty much be checking. You would do the horizontal line test to check if it's an inverse function, but you can't say that as your reasoning. You have to say it's not a one-to-one function. So you have to say that for each y value there's 2 x values, so it can't be a one-to-one function because all functions are one-to-one. Yeah. And then for this one, you're doing a regression. You would just enter these numbers in Desmos TID4, and you would check which of these 4 fit best. And then you would talk about, for this C.II, you would talk about like how as x increases so for example, x is increasing by 1 each time. So we know it's linear, quadratic, or exponential, because log for x values means it would change by a constant multiple. But we see f of x is dividing by 2 each time. So we know we're dividing by 2 each time, which means it's exponential, so 1/2. So this would be x is increasing by +1, and y would be increasing by y would be multiplied by 1/2, and that would be your reasoning. Wait, so limit notation looks like this. The limit as x approaches infinity of g of x is equal to infinity, or you can also write positive infinity. There's no latex in these channels, so this is how you do limit notation. You could also just, like, if you wanted to, you could also write out the equation. Doesn't really matter. So you could write this 0.1 x to the third dot 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 equals. It's an arrow. Yes, I know it's an arrow. Okay. It's written on the exam. Yeah, so for the FRQs, you write them in a test booklet. Yeah, on paper. Yeah. But the questions are online on your screen. MCQs are fully online, and you get scrap paper. The FRQs are on your screen, but you write your answers in a booklet, like on paper. So, like how we're looking at the FRQs online, you would have a book to write your answers in, and then you would submit that. Oh, you're asking. Oh, okay. I see. So now we'll go on to FRQ2. FRQ2 in 2024 was covering it gave you some data in the function, so you could write when t is 0 there's 40, when t is 91 there's 76. So now you have this. So the first question step is just to plug in these numbers into the equations. We have time to. We have a good amount of time. It's not even 30-ish minutes. So wait, there's a question. So for FRQ Desmos and questions online, and you just write everything, including your math, in the booklet. Yep. Yeah, all FRQs are on paper, handwritten, but your MCQs are online, and you select your answers there. Okay, for part B, you would, this is also a calculator question, so you could just put this in Desmos and figure out your answer. For part B, you would find the average rate of change, so you would do y2 minus y1 over x2 minus x1. Then you would use that to approximate t is equal to 50 by setting up point slope form. And then from here, you would continue to do that, and you would explain why it's a thing, and then you explain why the error is, why the model is inconsistent after t equals 91. And you pretty much just say that our data range is only from 0 to 91. In 2025, you did a similar things for part 1 and 2. And the only difference was part C, which just talked about maximum and minimums. And you just use that to find a domain. And that's the end of the calc FRQs. Now we go to non-calc FRQs. The first one is just using this data to find your maximums, minimums, and midlines. Part B was using those points to make an equation. So your plus D would be where your G and K are. And A would be your amplitude from F to G, and so on. And it's similar for both of them. And in part C, you'd be looking at, for example, it says K and P, and you would talk about if it's positive and increasing, etc. And you talk about how it's changing. Part A, I never know where to put T is equal to 0 for 2024 or 2025. So this one or 2025. This one, so radius of 9, T is equal to 0. Okay. Well, if you can't find out where to put T is equal to 0, you could start it not at 0, and then you could shift it to C. So it says point W touches the ground at T 1/2, completes the full rotation, and next time it touches is 5/2. So you could use 1/2, and then you could do 5/2 here, and then you could just find your values based off that. I just exercise your input and midline. Oh, it's fine. See, it's a mistake you made now, not on the test. Why assign a function? Because why is it a sine function? Oh, it's sine or cosine. So they only do sine and cosine for this, so it could be either or. So from there, now we get to FRQ4, which, as we said, is just solving. Don't do unit 4. It doesn't show up. They said specifically it's never going to show up, at least until they revise it one day, but not this year. Hi, Car. So FRQ4 is similarly, first part is setting both equations equal to some value and solving. I said unit 4 never shows up, so don't. Unit 4, which would be your parametrics. Okay, some teachers do teach it, but it's not tested, so. Oh yeah, my teacher did stuff similar. She did like extra stuff compared to studying for the exam, but it's all right. So you have to do what do you call it? You have to do. There's no parametrics, there's no matrices, and there's no conics on this exam, which is like all of unit 4. So part A covers setting equal. Part B is usually like a manipulation for both. Yeah, both of them are just manipulation. So this is trig manipulations. The first one is log. And the final one is just a function, exponential or trig, and setting it equal to 0 and solving. So those are your 4 FRQs, more in depth. So now some MCQs. Don't get it much. You'll see maybe a question or two on it. Do 1/4 are easiest? Are 1/4 the easiest? Yeah, I'd say my favorite's 4 because just like doing algebra. But FRQ 1's also pretty easy. Yeah, 1 and 4 are the easiest. Yeah. Okay. Or most people consider them the easiest. Some people consider FRQ 4 hard because of the algebra, but alright. So I'm gonna make a quick poll to see which MCQ you guys want to do for which unit. This is pre-calc for Morgan. What's the difference between 2024? It's just what year they were hosted. That's really it. And they're mostly similar. They follow a similar, very similar format each year. There's like slight differences in the parts. Yes, the same but different, pretty much. Yeah, the same formatting, but just different numbers, different equations, different context. Okay, it's tied between, okay, it's back to unit 2. Okay, there's only one vote. FRQ will be very similar question. Yeah, it's similar for calc. Though there's a bit more variation in calc's FRQs, but they follow like very similar format. Like the first 3 or 4 calc base, like use a calculator, and the next 3 don't. One FRQs being this long one with trigger identities, and they'll show the exact format. So yeah, if you remember the FRQs, I will pull up again. For example, like this one, you have to do a good amount of algebraic manipulation to get there. You have to use your trigger identities. Yeah, you have to memorize them. Okay, so unit 2 is winning, so we will do some unit 2 MCQs because we're gonna be doing them again tomorrow. So hold up. Would you rather play a GIMP kit on the unit 2 MCQs? Because I put these MCQs on a GIMP kit. 3. I mean, wait, 3. Hold up. Pick. If we're doing 2 tomorrow, yeah, we're doing unit 2 tomorrow at 2:30. So that's the link for tomorrow's lecture on unit 2. So unit 3 is, I guess, the popular opinion right now. 1, okay. Alright, hold up. Let's make a poll real quick. 1, 3, MCQ. I'm just letting them pick because 1 is fine. Okay. 1 is winning. Okay, we'll do 1. Okay. PDF. Let me download it real quick so you have it. Okay. Let me open it up real quick. Okay. We'll do like 1 from each section. How about that? So I'll give like a minute for this because this is. I'll give like 2 minutes for this because this is mostly just reading. There's not much math in this question. This is a context question. This is 1.1. This is just this is context. Oh yeah, spoiler answers, which you do by doing this on both sides of your answer. multiple choice. These are multiple choice, yeah. Okay, we got 2 answers so far, not 3 answers. I'll wait for like another 2 answers and then I will call it. Okay, the answer is A. Because as you see, it's first a constant rate, so we know we can take out B because this says increasing his speed, so that would be more like curved in some way, so it would probably be curved like this. So it stops at restaurant, so that would be your pause. And then finally it says drives until he reaches his house. So that would be A. And it wouldn't be C or D because that would be the other way around. Because it says leaves his house. That means distance from home would be going away, not towards. Okay, now we will do question. We'll do 6 through 10. We'll do this entire set. So we'll do 6 through 8 first. I will give until 9, 13, because there's not much math in this. Okay. By the way, we're doing 6, 7, and 8. Can't see the rest. Oh. Wait, is it just because the way I'm sharing, or is it because the device you're on? Hold up. It's a share. Okay, then we'll just do one at a time then. Is it me or is it blurry on my end? Does that fix it? I have questions. Yeah, if you're not AP release, yeah, this is the time. Alright, for 6, the answer is C. And the reason for that is there's 3 inflection points. There's one here, there's one here, and there's one, I think, here, if I remember correctly. Is flip math reliable for self-studying this? So, yeah, inflection points where concavity changes. So, it's good for self-studying some of it, but it's always good to get some AP style questions. So, as you see, we're going through this like Brian Passler one right now currently. So, there's like some good resources on this doc right here. Yeah, you can find it on this doc as well. It's easier because we have a link for it. So you can just like grind through these questions. There's like, I think 300 and I think 400 in total between all 3 units. So, yeah. Alright. Next question. Yeah, Fiverr does suck. There's too many ads. Okay, I will just do 7 now. I use something called Drawboard PDF. It's just something I found the Windows thing when I was starting out in 5.5. Okay. So on the interval 7 to 9 is f of x, positive and increasing, positive and decreasing, negative and decreasing, and negative and decreasing. I have one answer, two answers. Can you remove lines? Oh, yeah, my bad. I'll erase these. Yep, everyone got C, and that is correct. Okay, I can't show the graph in the same one at the same time, so we're gonna go to the next question. We'll go to a new topic. We will do 16 and 17. And as a reminder, make sure to fill the lecture feedback form before you leave. You have one answer. Okay, 16 is A and 17 is C. And the reason that is you see the function for 16, we see the function is increasing, and it's increasing faster and faster as we go because our slope is getting higher. For 17, we see the function is decreasing, and it's an increase at an increasing rate because we're going from a slope of, like, let's say -5 to -4 to -3 to -2. So our slope is decreasing at an increasing rate. So our rate itself is increasing. Our slope is yeah, look at concavity for rate of change. Does that make sense? For why? Because as we see, our slope our slope itself is increasing slowly. And if we kept going, we would get like -0.1 eventually, which means we started at a slope of -5 and we got to -0.1, which is a slope that increases. We'll do 2 more of these. Okay, we'll do 18 and 19 as well. Look at the slope, not just look at the actual values of the slope is what my tips would be for these questions. Yeah, that works as well, but that's kind of calculus as a little bit as well, so. There's no harm, but you can't use that in your explanations, so, because this is pre-calc. Okay, we got 2 answers so far. Yeah, for calc MCQ you could, but it's better just to do the same thing you're supposed to be doing. Yeah, D and B are correct. And 18 is D because the function is decreasing and it's getting negative, let's just say negative faster. It's going like -0.5 to like -1 to -2 or 3 and so on. And this is increasing at decreasing. It's increasing at a decreasing rate because the function is increasing, but our slope goes from like 5 to 4 to 3 to like 1 and so on. So you're looking, the first part when it says increasing is you're looking at where the y values are going. And this rate, you're pretty much looking at if the slope is increasing or decreasing. Yeah, you can also look at it like smiley faces and frowns. So if it's concave up, it's a smiley face. And that means our rate of change will always be increasing. And concave down would be this. And the rate of change is always decreasing because it's starting at very positive values and it's getting to 0 and then it's becoming more and more negative. Okay, so if it's increasing, it's normal. I wouldn't say think about it like that. I would think about like how the slope itself is changing, like the rate of change as you go on. Is how I'd say. It's better to think of it conceptually than. Okay, so we'll restart for this one, for example. Okay, so let's say we have a line here, right? That's going straight up, right? Like the slope at this point, like our instantaneous rate of change that we talk about at one point, like I think 3, for example. What would be the slope of this? Like just say a number that makes sense. 1/3. Okay, we can say 1/3. Okay, I would say 7 is better answer because then you can keep getting smaller. So now we're going to change colors to make this clear. So now let's pick a point here. If we drew a tangent line to this point, or an instantaneous rate of change, what would be our slope here? Yeah, 5. Now we'll take another point. We'll do here. And now we're going to draw another line. And let's say a slope here, 3. And then we keep going. And as we keep going, we're getting smaller and smaller until eventually, yeah, sure, which one? This one, like 18, or one of the above ones? 18, okay. So let's say we start again. We'll start here. Let's say what's the slope at the top of this line? We'll start at the top this time. What's the slope at the top of this line? 0. Okay, so now we're gonna change into another color. Now let's take the slope here at this point at 1. So now we're gonna draw a line. What's your slope at this point? -1. Okay, now we're gonna take another point and we're gonna continue on. Right, let's take 2 now. Hold up. Okay, now we take 2. What's our slope here? Yeah, let's say -3. And now we're gonna take another one. I'm just gonna jump down here real quick. Let's take it all the way down here. Let's say where our slope would be here. It's pretty vertical, almost vertical line. -6. So as we saw, our slope went from 0 to -1 to -3 to -6. So what would you describe that as our rate? What could you describe that as our rate? Is our rate increasing or decreasing? It's a decreasing rate. So now we know it's not A or C. And then we see our function is decreasing. So we know it's D. All good. See, that's what one of the expectations was. If you learn it, if you make the mistake now, you don't make it on the AP exam. I will continue onwards then. If there's no other yeah, we have more. We have tons more. This is like the most common question on this thing. It's like 20 of them. Is this the conceptual part behind the rate? Yeah, this is the conceptual part. Understanding how the rate is increasing, decreasing, the instantaneous rate of change, stuff like that. And the instantaneous rate of change is more like your tangent line. So like when you or when you calculate your point slope, that would be your instantaneous rate of change, is a better way to put it. When you calculate your point slope at this point, that would be your instantaneous rate of change slash point slope slash tangent line. So there's multiple ways people call it, so I'll call it all of them for RT's sake. We'll do 2 more of these and then we'll move on to like the next topic. We'll do 20 and 21. Okay, we got 2 answers. Oh, we got 1 answer. 1 person answered by a statement. Two answers, and I think that's gonna be it. So I'm gonna continue onwards. So yep, 20 was B, and 21 was D. Great job. So now we're gonna continue on to the next topic, which because the next question is just the same repeated stuff. So we're gonna skip all these. Talked about rates of change, so I'm gonna change onto some more algebra-based topics. That's still rate of change. I will do 1 calculation question. What is the average rate of change? We'll do 54. And as we're getting to 9:30, remember to fill lecture feedback form before you leave. But we'll continue on until around 10 for today. And then tomorrow we'll do 2 to 3-ish hours. We'll see. For unit 2. So what is the average rate of change of f over the closed interval 0 to 3? Okay, about 30 more seconds for this question. Okay, so I guess people are stumped or okay now time. Oh, okay, just wasn't updating. Okay, guess I like that. Okay, so the way you do these is it says over the closed interval 0 to 3. So we're gonna look only at 0 to 3 at x is equal to 0 and x is equal to 3. So for this one, we would do y2 minus y1, so 4 minus -2 over 3 minus 0, so 6 over 3 is 2. For 55, we would do similar idea. It says 3 to 9, so we would do -1 minus 2 over 9 minus 3, which would be -3 over 6, or -1/2. Alright, continuing onwards, the average rate of change. Let's go to some modeling questions. Start with this one. Well, that's AP for you, Morgan. There's a lot of words. AP questions love their words because that's how they get people. For people who don't read the question, that's how they get people. So, yeah. Okay, this shouldn't take too long, so we'll give like a minute for this. Okay, we got one answer so far. Two answers so far. Three, and see if we get one more maybe. So now we're gonna look at, so everyone chose D, which was correct. And the way you would do this is you would look at first the X, so we see it's going by +1 each time. So we know the second part, consecutive equal length intervals is constant, is true. Our second part, this goes -2. This goes +1, +4, and +7. And then, as you see, this isn't linear because we see it's not constant. So we're going to do one more. Because if we remember, quadratics is the change in the average rates of change are constant. So we're going to do one more. So -2, 1 is 3, +3, +3, and +3. So now we know it's quadratic. Or the second order difference is, because the second order difference are constant, it's a quadratic is another way to say this. We'll do this one. Do 70. And you'll see this question throughout Unit 2 as well, but now you'll have exponentials and logs with them as well. So you'll have linear, quadratic. You can sometimes have cubic, and then you'll have exponentials and logs for sure. So I'll give like a minute to solve this. Okay, we got 3 answers, so I'll wait like 30 more seconds before revealing it. Okay, I will go over it now. So the answer is D, and it's D because similar strategy you would do +1, +1, +1, +1. And this is going -2, -3, -4, -5, and then you would be going -1 as our second order difference. So it's a similar idea of consecutive equal length intervals because the average rate of changes are constant. Or it can be given by a linear function is another way to say it. Okay, We did all these concavity questions. Now we'll do some polynomial questions. Some algebra. We'll find some algebra questions. 82. That works. Which of the following could be an expression for g of x? And remember, for this, you're looking for anything to the power of, let's say x to the 1 is something that goes like a line. X to the 2 is something that bounces. X to the 3 is something that looks like a cubic usually. I can't draw a cubic, so I'm just gonna pretend it's a cubic. And then x to the 4th is like a quadratic. Okay, we got 3 answers, 4 answers. I'll give like one more second and we'll call it a day. See, okay, we got 5 answers. So yeah, the answer is C, because at -3, we have a point here that goes straight down. So that follows our x1 pattern. And then our x minus 2 is cubed, and that follows our cubic pattern. And we know it can't be A, or it could be A, but we see it's squared, so that means it must bounce. So this can't be it. Yeah, sure. What's the question? Is it cubic if it's bouncing like a line? Yeah, so if it's the power of 3, it looks like a cubic. So if we go to Desmos, if you remember what a cubic looks like, it has this like distinct pattern to it always. So a cubic will always look like this. Like if it's the power of 3, it'll always look like this at that point. And that's how you can tell if it's a cubic or not. If it's the power of 3, if it looks like a cubic. And you can say it's similar for x to the 5th as well. So x to the 3rd, x to the 5th, they all look similar. And you can say the same way x to the 2nd and x to the 4th look also like that. Okay, we'll do this question. 84 looks different. The table gives values of the polynomial function g as selected values of x, which of the following by g could be true. Got even and odd functions. Okay, I'll give like a minute for this question because it shouldn't take too long. We got 2 answers. Three answers. All right. Okay, I'm gonna go over it now. The answer is B. And the reason for this is we're gonna start at, we're gonna first figure out if it's an odd function or an even function. So we're gonna look at 2 similar pairs of coordinates. So we're gonna look at -4 and 4. And if we remember, an even function looks like this. So that means if we plug in, let's say, f of negative x, right? So if we plug in negative f of negative x, it should equal to f of x because it's symmetrical on both sides. But if we plug in f of negative x with an odd function, which usually looks like, let's say, it's like a line, for example, it looks like f of negative f of x. So if we look at negative 4 and 7, this flips to 4 and this flips accordingly, which matches, if we remember, like a cubic function. Like negative 4, 7 would be up here, and 4, negative 7 would be up here. So that matches our cubics. So that makes sense. So this is an odd function, so we know it's not C or D. And then we have g is equal to negative 1, g add negative 1. And we see at 1, it's negative 6, so it has to be the opposite, so it has to be 6. Does that make sense for everyone? 84. Okay, if there's no questions, we'll continue onwards. Do some sign charts now. Good old sign charts. We'll do 80. We'll do 88. Okay, we got one answer. Okay, I'll give another like minute or two for this question because it takes a bit longer to do. Okay. Okay, okay, I'll go over 88 now. For 88, the answer is D. And the reason for that is you would first, we're going to graph out our x-intercepts. So we have 0, 4, and negative 1. So we're going to put a 0, a 4, and a negative 1. So now we're going to test points in between these intervals and outside these intervals to test if it's going towards infinity. I'm pretty sure I'm talking because Discord's showing the audio, but let me know. It's just damn okay. Alright, cool. So when I first test the point outside the interval, we're just gonna go in order. So when I first test negative 2. Alright, so we're first gonna try negative 2. So I'm gonna do this in a different color so this is easier to see. When I first test negative 2. You could do end behavior, but sign charts are like easier, and most people agree on that. And it's useful for calc as well to do sign charts. So it's like a double win. You learn how to do them correctly. So if we do negative 2, we would plug it in and we would get a positive as our first Our second one will be negative, and our third one will be negative. So this would end up being positive, because this would be a positive times a negative, which would eventually be a positive. So now we're going to test a point in between. So we're going to try negative 0.5, because that's like the only easy point. So a negative times negative is a positive. Negative 0.5 would be negative, and this would be positive. Yeah, this is calc active. This would be super easy. So this would be positive. This would be negative, because we have a negative sign here, and it doesn't cancel out. So now we're going to look at our next one, 0 to 4. So now we're going to plug in 2. Our first one will be negative, negative, positive, so it's going to be positive. And then finally, we're going to plug in 5. 5 will be negative, this will be positive, and this will be positive. So this will be negative. And we're looking for where it's less than 0, so that would be negative 1 to 0 and 4 to infinity. Any questions? Are you getting these positive and negative signs? I'm pretty much plugging them into this. So we'd be plugging them into our original function. So we plugged in like negative 2. We would be plugging in negative. So we'll do it up here. G of negative 2. Our first one would be negative 2 times negative 2, which is 4. So that's positive. Our next 0, x minus 4. We would plug in negative 2. We would get negative 6. So we would keep our negative sign. And then x plus 1. We would plug in negative 2. And we would get negative 1. So it's negative. And if you wanted to try to graph it like this, you know it's a cubic, so because it's to the power of 3 and it's negative, so it's going to be going down like this way. So we're going to do, there's a point at 4, there's a point at negative 1, and there's a point at 0. So we're going to go down, up, and then down. And if you were to do a graph, you would see that it's the same idea, negative 1 to 0, and 4 to infinity. So you could do a graph if you wanted to. But if you mess up the graph, it's easier to make a silly mistake. Okay, does that make sense for sign charts? Because you'll see this again in Unit 2 with logs and exponentials. Someone's typing, so I won't scroll yet. Do you do yeah, you do sign charts in Unit 2 as well when you have to do inequalities with logs and exponentials. So we'll be doing, I think, we're not doing too many sign charts tomorrow, just 2 of them. But yeah, we do sign charts again. Because, see, you could graph these, right? But then what are you going to do when you have an exponential log? It's going to be harder to graph those and find your points. That's why you usually do sign charts. Okay, we'll do one more sign chart. We'll do this one. We'll do 93. It's a bit different, so we'll do 93. I'll give until 9:50 EST, so 3 minutes. That's too much work. Not trying to factor. Well, it's better to factor now and practice, you know what I mean? Oh, you're on your phone, I see. Alright, no problem. Have a nice day or night, depending on your time zone. Alright, go over the question now. So this is where f of x is greater than g of x. So we're first gonna set it equal like that. So we're gonna say x of 2 minus 5x plus 10 is greater than 2x squared minus 3x minus 14. So we have negative x squared minus 2x plus 24, and then we're gonna, which is greater than 0, and then we're gonna factor out the negative. So we're gonna do negative of x squared plus 2x minus 24. Then we're gonna factor that, and 24 has a factor of f of x plus 6. Rewrite that. X plus 6 and x minus 4, which is greater than 0. So now we're going to set up our sign chart with 4 and negative 6. We're going to plug in, first we're going to plug in, let's say, negative 7. We first have a negative on the outside, negative, negative, which means this overall will be negative. We're going to try negative, we're going to just try 0 in here. This will be negative, positive, negative, which should be positive overall. And then we're going to try 6, which should be negative. Oh, okay. We're not going to try 6 because there's... Wait, I might have messed this up. Hold up. Okay, you can't keep a negative. Hold up. You have to divide by it. I might have messed up somewhere. Hold 1 sec. Nope, wait, I didn't mess up. I'm dumb. 1 sec. Alright. And then we're going to try like 7, and then that would be negative, positive, positive, which would be negative. And that lines up. And we're looking for it where it's greater than 0, so that's C. And that's your answer. My apologies for the little mix-up. Does that make sense? Looking at where f of x is greater than g of x, yes, so we set it up equal to each other, and then we solved for where we set equals. So let's say we have f of x and g of x, right? And it says f of x is greater than g of x, so we're going to say x squared minus 5x plus 10, which is our f of x, is greater than g of x, which would be 2x squared minus 3x minus 14. And now we can solve for in terms of 0. So we're going to subtract everything to the other side. I'm not setting it equal. Yeah, it's made greater than 0 because we can't solve this. We don't know how to solve this with a calculator, but we know how to solve it when it's greater than 0, less than 0, less than, greater than, or equals 0, all that stuff. So we're just solving in terms of something we know how to do. Okay, we will do one more question. I pick a number between 1 and 183, and that'll be the last question for today. 156, okay. Not too far. Oh, okay, here we are. Okay, 156, okay. I'll give like 2-ish minutes for this. Okay, we got one answer. Let me check who else is in this to see if I'll get more answers. We might get more answers, so I'll wait. Okay, we got two answers. Let's see if we got one more. Okay, one person typing. The person stopped typing, so I guess they're not going to attempt. So the answer for 156 is C. And the reason is, so with a horizontal dilation by a factor of 3. So we're going to be doing g of x is equal to f of x divided by 3. Because it says a dilation by a factor of 3. And horizontal stuff are always inverses. Then it says a vertical dilation by a factor of 5. So then 5, and then we're going to subtract 7. So that'd be C. Okay, so now let me go back to this. If there's no questions, that will be the end of today's lecture. And as a reminder, please fill the lecture feedback form before you leave. So if there are no other questions, that will be it for today's lecture. And we'll spend I'll wait 4 minutes for any questions. And this will be uploaded to YouTube shortly, probably by the end of this weekend. No problem.